If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in intermediate level where we are solving questions on differentiability from previous year JEE Main question paper. So in this lecture we will be solving question number 4, 5 and 6. Okay, then let's try to solve these questions. If fx is equal to this, which of the following is true? Fx is differentiable, again we have to check. They are saying differentiable all these options. So let's check at 0 and 1. You can see the breakpoint is at 1. So continuity, if you check, that means otherwise it will be always continuous. At 1 if you check, so in case of left hand limit, right hand limit, if you put a number very close to 1, so this will be 1 by 0 infinite. So whatever give you input of sign, the output is always from -1 to 1. So that output will be multiplied by 1 minus 1, that is also 0. So 0 into some finite output it will get, you don't know which one, it can be oscillatory. But it is not infinite. Sin infinity is not infinity. Sin infinity will give you some value from -1 to 1. You don't know what value. It can be any value because you don't know what input you are giving. You are giving a huge number, but what is that number you don't know. But the output will range between -1 to 1. So that output, if you multiply with 0, so output will be 0. So your left hand limit, right hand limit both are 0. So no need to check continuity. Directly we are doing derivability. Left hand differentiation and right hand differentiation. Now you can say you cannot segregate this function greater than 1, less than 1. The same function you will be dealing with. So you have to use original definition of the left hand limit, right hand limit. Suppose if I am doing f dash 1 minus, at 1 I am checking. Then I will check at 0 also. It will be limit h tends to 0. F of 1 minus h. So this was the actual definition. So if you do this one, it is minus h. F of 1 minus h will be, instead of x you will put 1 minus h minus 1 sine of 1 by 1 minus h minus 1 minus f of 1, and they have also given f1 is specifically they have given 0. So if you put h, 1 get cancelled, so it is actually sine of minus 1 by h. So you don't know what value it will be because it will be oscillatory. If you give x0, h0, it will be infinite. Some finite will come, but it will come between -1 to 1. Which one come you don't know. So from here itself you can say, you see your right hand derivative also. If it is same as this one, 1 plus, that is limit h tends to 0. Now it will be f of 1 plus h divided by h. So it will be 1 plus h minus 1 sine of 1 plus h minus 1 minus 0. So again h's get cancelled. You will find limit h tends to 0 sine of 1 by h. You see the difference between two. Here it is a minus is there, here no minus is there. So these are not equal. Even whatever it gives, if it gives same, but it will give of opposite sign. So your LSD will never be equal to RSD. So therefore not differentiable at x equal to 1. So option A is gone, B, C is gone. So it will be out of B or D, whatever. Now instead of x you will be putting minus h. So it will be minus. What is f0? If you put 0, then it will be 0 minus 1 minus 1 and sine of 0 minus 1 minus 1, the sine of minus 1. So minus you can take common, minus you can take common. So it will be 1 plus h sine of 1 by 1 plus h, and it will be minus sine 1. Minus minus minus, it will be sine 1 divided by minus h. Now if you put h equal to 0, it is sine 1 minus sine 1, that is 0 by 0 format. So you can apply L'Hopital rule without using and wasting any time. So if you apply L'Hopital, this is minus 1, and here you have to do this differentiation. If you take 1 plus h common, constant, sine differentiation is cos, and then differentiation of this one, 1 plus h whole square plus sine 1 plus h, if you take constant, then differentiation of 1 plus h is 1. This is 0. Now you can put h0 and you can see what it is. It is 0, then it is 1. It is 0, that means cos 1. It is 0 means minus 1. And it is 0 means sine 1. So it is sine 1 minus divided by minus 1. So it will be sine 1 minus cos 1. Similarly you can do your RSD also. F dash 0 plus. Now it will be f of 0 plus, and here it will be plus h. So again f0 will be same this one, so you can write it minus sign. Same 3 minus will come. Okay, now again if you differentiate it, you will get it because it is 0 by 0 format. Again you can apply L'Hopital rule. So again you do this differentiation, you will get this one, sin h. If you put it finally, you will get again sin 1 minus cos 1. So your LSD is again RSD. Again I am saying, those who don't know differentiation, just wait for some time, we will be doing for differentiation. So it is differentiable at x equal to 1. So it is differentiable at x equal to 1, but x equal to 0, but not at x equal to 1. So which one will be your answer? That is option D. It is differentiable at x equal to 0, but not x equal to 1. That is your option D. Now if you come to question number 5, if f is from -1 to 1 to r is a differentiable function with f0 this, f dash 0 this, let g is equal to this, then g dash 0 is equal to. So I think it is of differentiation, but it's mentioned here, okay, no issue. So it is of f of 2 of f of x plus 2. This square is on the third bracket, so there will be one third bracket, then this square, kindly correct it. Okay, so if you do differentiation of g dash, if I am doing differentiation, so it is a chain rule. First you do the outer, this is the outer function, then you go gradually inside. So if you do outer function, then it is something square is 2x, 2 into that something, then you have to do the inside one, so it is done 2 into something. Next you do integration, differentiation of this one inside this one. So this differentiation is f dash of this one, because you don't know what is the differentiation of this one. So f differentiation is f dash. Now you go inside this one. Inside this one is 2 into differentiation of f is f dash plus differentiation of 2 is 0. So first I have done this outer third bracket, then this f, then this inside this bracket. Now you need to find g dash 0, they are asking. So you put just 0. If you put f dash 0 is 1, and your f0 is -1. So f0 is -1, so it is -2 into -1. So again 2 it is 2 f0, 2 again it is f dash 0. So answer is -4, that is your option B. Now if you come to question number 6, consider this function fx. F dash 4 is what? Fx is continuous in 2 to 4, differentiable in 2 to 4, and f2 equal to f5. So let us write this function by opening this mod functions. So here you can say this function, there is a break at 2, because for greater than 2, less than 2, it will be different function. Here also it is break at 5. So you have to do it in step by step. So if I break the function for x less than 2, so one break is at 2, if you see number line, one break is 5. So what I will do for first this break less than 2. If it is less than 2, then this is also negative, this is also negative. So you have to put a minus sign before both that. So this is for this one. Now we will do for x get in between 2 to 5. So in between, if it is greater than 2, then this is positive, no need to put minus, but it is still negative because it is less than 5. So if you are removing mod, you have to put a minus. And next, if x is greater than 5, if x is both are positive. So finally, if you write it, your fx will be equal to -2x plus 5 plus 2, 7 for x less than 2. For x between 2 to 5, it is x is cancelled, it is plus 3. So this is your final function. So if you draw the function now, so this is at 2, this is at 5. So between 2 to 5, it is plus 3 at some constant level, it is constant. After 5, it is 2x minus 7. 2x means increasing slope, and it is minus 2x means it was decreasing slope. And this position is 7 obviously, because it is y equal to mx plus c. So that is not of my concern. So this is the graph. Now the first statement is f dash 4. So if you do differentiation in f4 is here. So if you do differentiation here, what will be your f dash? F dash will be 0 because it's constant. Here the function output is constant. What is the output? 3. So it is constant, so differentiation is obviously 0. So statement 1 is correct. Statement 2, f is continuous between 2 to 5. Yes, it is continuous between, you can draw it with single line stroke 2 to 5. Differentiable at 2 to 5, okay, you know the differentiation of this one is 0. f2 is equal to f5, okay, both the height are same, 3, 3. So 2 is also true. But 2 is the correct explanation for 1. What is 2? 2 is say it is continuous, it is differentiable, and f2 equal to f5. If f2 equal to f5, it doesn't mean that f4 is equal to 0 also. It can be also this function. If you see statement 2, this is also true for statement 2. It is continuous between 2 to 4, it is differentiable, f2 equal to f5, but f4 is not 0, you can see. f4 you will find some function value. Tangent, if you do differentiation, you will get some tangent. But here it is constant, no tangent, flat tangent, that is 0. So that's why 2 is not a correct explanation. Not a correct explanation, because 2 doesn't implies that differentiation of x at 4 it is 0. They are saying just 2 and 5 are equal, but what is there 4 they don't say in statement 2. So with that you cannot say that in between 4 it will be 0 differentiation. So not correct expression, that is your option B. If you like the video, then press the like button and please give your valuable comments in the comment section.